Here we will see event-driven programming. Event-driven programming is a programming paradigm where external events determine the flow of program execution. These events come from different shapes like user actions where button is clicked or key from keyboard is pressed, system events like finished file download, or messages from other programs, sensor outputs, etc. Here program waits for events and react them as they occur by using appropriate event handling procedure which allows for greater flexibility and responsiveness in applications. Event-driven programming is often asynchronous and it is particularly popular in graphical user interfaces, real-time applications, and IoT use cases. Event-driven programs are made up of smaller procedure-driven programs. When users do an event, the program sends the appropriate input to the procedure which computes and sends some result to the main program. Events interact with three other key components of an event-driven system: event source, event listeners, and event handlers. Event source, also known as producers, generate and publish events such as button clicks or sensor data. They notify the application about these events without knowing which components are listening or handling the event. Then event listeners, also known as subscribers, register for specific events and respond when they occur. When an event occurs, the listener is notified and calls the corresponding event handler, which executes the code to handle the event. And event handlers are the functions or methods processing the event. They perform tasks such as updating the user interface, making API calls, or triggering other events. Here we will see an event-driven architecture when user clicks a button which triggers an action. Here event source is the button click event. When button is clicked, the flow goes to the event listener. Here event listener listens for the button click event and specifies which event handler to call. The listener places the event in the queue where they are stored until they can be processed. The queue also helps to manage concurrency and synchronization issues that arise during the event. Event loop runs in the background constantly, checking the queue for events and calling the corresponding event handler. An event handler is the callback function that is executed in the response to an event. That is, when button is clicked, the control passed to event listener. Event listener sends this event to the event queue, and event loop checks the events in the queue and hand over the event to the event handler, which calls the function to execute the event. Advantages of event-driven programming are responsiveness. Event-driven programming enhances application responsiveness. Here user actions or system events trigger immediate responses, which ensures that the application remains interactive and efficient. For example, weather alert system can quickly notify users about severe weather conditions. Then scalability. Event-driven programming supports scalability. Systems can handle numerous events simultaneously without performance degradation. This capability proves essential for applications like real-time data utilization. Businesses can process information between applications, microservices, and connected devices efficiently. This scalability empowers developers to build robust and high-performing systems. Then flexibility. Flexibility represents a significant advantage of event-driven programming. Developers can easily add or modify components without affecting the entire system. This modularity allows for quick updates and enhancements. For example, a financial trading platform can integrate new market data source seamlessly. This flexibility enables business to adapt to changing requirements and maintain a competitive edge. And disadvantages of event-driven programming are complexity. Event-driven programming introduces complexity. For managing multiple events and handlers requires careful planning and designs. Developers must ensure that events do not interfere with each other. This complexity can increase development time and effort. Proper documentation and testing become crucial to maintaining system stability. Then debugging challenges. Debugging event-driven applications presents unique challenges. Events can occur asynchronously, which makes it difficult to trace issues. Developers need specialized tools and techniques to identify and resolve problems. For example, logging and monitoring tools help track event flows. Effective debugging practices are essential for maintaining application reliability and performance overheads. Event-driven programming can introduce performance overheads. The event loop and event handlers consume system resources. Inefficient event handling can lead to increased CPU and memory usage. Developers must optimize event processing to minimize these overheads. Techniques such as load balancing and resource management help maintain optimal performance.